Welcome everyone. Through this video, I am going to discuss differentiability by graph. To check differentiability from graph. So to check differentiability from graph, we should have basic idea of graph. Graph of mod x, graph of x square, graph of x cube, graph of e to the power x, basic graphs. So we start by a basic example. So suppose fx equals to mod x. So to check differentiability at x equals to 0. So look at x equals to 0. So this is graph of y equals to mod x. We know y equals to mod x is continuous function, but not differentiable. So look, from graph, this is y equals to mod x. At x equals to 0, look, the graph has sharp edge. So if a graph has sharp edge at a point, then it is not differentiable at x equals to 0. This type, suppose this is a straight line, this is a curve, sharp edge, then it is not differentiable at x equals to 0. X equals to 0, so sharp edge not differentiable, but it is differentiable for x greater than 0, less than 0 and so on. Now problem number 3. So graph of a function is given, this type of graph. Verify differentiability at x equals to 1. Look, at x equals to 1, it has sharp edge, so not differentiable at x equals to 1. So actually it is graph of y equals to mod x minus 1. Now fx equals to mod x plus mod x minus 1 at x equals to 0 and x equals to 1. Now look, for x greater than 1, for greater than value, both are positive. So 2x minus 1 for x greater than equals to 1. For x less than 0, it is negative. So minus x, this is 1 minus x. So 1 minus 2x, x lesser than equals to 0. And in between 0 and 1, less than 1, so it is negative and it is positive. X plus 1 minus x equals to 1. So if we draw the graph, so this is 0, this is 1. So 0 to 1, y equals to 1. Suppose y equals to 1. This is y equals to 1. This is 0, 1. Y equals to 1. 0 to 1. For greater than 1, y equals to 2x plus 1. So y minus 2x equals to 1. So this is 1 minus 2x. This is 2x minus 1. Sorry, 2x minus 1. Y equals to 2x minus 1. So y minus 2x equals to minus 1. So x by half, y by 1 equals to 1. So x by half, y by 1 equals to 1. So if you draw a graph, so we get figure like this. So this is y equals to 2x minus 1. Now it is valid for x greater than 1. So this part is not present. This part is not present. And y equals to 1 minus 2x. So 2x plus y equals to 1. X by half, y by 1 equals to 1. X by half, y by 1. So we are getting So this part is absent. This is 1 minus 2x because it is x lesser than equals to 0. So graph of mod x plus mod x minus 1 is like this. So it is obviously continuous at x equals to 0 and 1. Hence it is continuous for all x. But look, at x equals to 0, it has a surface. At x equals to 1, it has a surface. So it is not differentiable at x equals to 0 and x equals to 1. So these are basic concepts. Now using this concept, we now try to solve some problems of JEE Main and Wbjee. Now using this idea, we now try to solve some problem of JEE Main. So fx equals to minimum x comma x square. Then which one is true? More than one option may be true. So fx is continuous, fx is differentiable, f dash x equals to 1 for all x greater than 1. Not differentiable at exactly 2 points. So first we draw the graph. So there are two graphs, y equals to x and y equals to x square. So x equals to x square. So x into x minus 1. So x equals to 0, 1. So y equals to 0, 1. First we try to get point of intersection of these two curves. So point of intersection is 0, 0 and 1, 1. So y equals to x. This is y equals to x. Y equals to x. Now y equals to x square. At x equals to 0 it is 0. At x equals to 1 it is 1. At x equals to minus 1 it is also plus 1. So this is parabola. This is parabola this type. Now minimum x and x square. This is one graph, this is one graph. So minimum. So minimum value. So out of these two graphs, so this is 1, 1. So this point is 1, 0. And this is 0, 0. So minimum, so this curve is cancel out. This is cancel out. And from 0 to 1, so minimum, this one is minimum. So this is cancel out. And for greater than 1, so which one is minimum? This. So this one is cancel out. So we are getting figure like this. So y equals to x. So in 0 to 1, so this is a parabolic arch. Then again it is y equals to x. This is y equals to x. This is y equals to x square. At 0, this is at 1. So actually this one is not same curve. This is parabola. So look, f is continuous for all x. So there is no break point. So option 1 is correct. F is continuous. F is difference. So look, at x equals to 0, there is a surface. And at x equals to 1, there is a surface. So it is not differentiable at x equals to 0 and x equals to 1. Not differentiable. So what is the option B? F is differentiable for all x. This is not correct. F dash x equals to 1 for all x greater than 1. So this is fx. For greater than 1, what is fx? Fx equals to x, x greater than 1. So f dash x equals to 1 or x greater than 1. This is also correct option. And if x is not differentiable at exactly 2 points, what are the points? 0 and 1. So 3 options are correct. So very simple, you need idea of graph of x and x square only. Now we consider one more problem, same type. If R2R be a function such that fx equals to maximum x and x cube, find the set of point where fx is not differentiable. So x comma x cube. So x into x square minus 1 equals to 0. So x equals to 0, 1 and minus 1. Point of intersection. Now we try to solve graph of function. Now y equals to x. So this is line passing through origin. Y equals to x cube. So at x equals to 0, it is 0. At x equals to 1, it is 1. Because y equals to x, at x equals to minus 1, y also minus 1. So this is 1, this is minus 1, and this is 0. So between 0 to 1, between minus 1, 0 to 1, 0 to 1, x cube less than x cube less than x. So graph will be like this. And here minus 1, this is minus 1. This is graph of y equals to x cube. And this is y equals to x. Now, we draw the graph using restriction maximum. Now look at less than minus 1. Two graphs, this and this. So this is maximum. So this is y equals to x. This part is not present. Between minus 1 to 0, this one is maximum. So this part is absent. Between 0 to 1, so this part is absent. This part is absent. So we are getting figure like this. So this is minus 1, this is 0, this is 1. At 1 it is 1. At minus 1 it is minus 1. So 0 to 1. This is x. Then x cube. Y equals to x cube. This is straight line. This is graph. Then here y equals to minus x cube. Sorry, x cube. This is y equals to x. Then y equals to x. So this is a surface. This is another surface. To define type of curve intersect. This is another surface. So surfaces are minus 1, 0, 1. At surfaces, it is not differentiable. So the function is not differentiable at minus 1, 0, 1. Most important problem and interesting also. Now we consider one more problem. Fx equals to minimum 1 x square x cube. So 1 equals to x square. So x equals to plus minus 1. X square equals to x cube. So point of intersection 0 and 1. X cube equals to 1. So x equals to 1. So point of intersection minus 1, 0, 1. 3 points of intersection we are getting. Now graph. So x-axis, y-axis, 0, this is 1, this is minus 1. So y equals to 1. So this is y equals to 1. Now y equals to x square. At x equals to 1, it is 1. At x equals to minus 1, it is also 1. So y equals to x square. This is graph of, so we know this is parabola. Now y equals to x square and y equals to x cube. In 0 to 1, x cube less than x square. We know if value lies between 0 to 1, so value of x cube less than x square. And for greater than 1, x cube greater than x square. So curve y equals to x cube will lie below y equals to x square. But for greater than 1, x cube will be greater. So this is y equals to x cube. This is y equals to x square. And similarly here also, y equals to x cube. In minus 1, this is minus 1. So this is y equals to x cube. Y equals to x cube. This is y equals to x square. Now, look, it is given minimum. So this is one curve in minus 1. Less than minus 1. Look, this one, y equals to this and y equals to this. So this is minimum. This, and this. So we are getting only this part. This part is cancel out. This part is cancel out. So we are getting this one. In 0 to 1, if it is minimum, so this one is minimum. So this part is cancel out. So this part is cancel out. So we are getting only this part. Then this is y equals to x cube. This part is cancel out. This part is cancel out. And y equals to 1, x square, this. So this is minimum. So this part is cancelled out. This part for greater than 1. So we are getting a figure. Look, this is minus 1. This is minus 1. This is y equals to x cube. This is 1, this one is 1. This is y equals to x cube. So this one, y equals to x cube. This is minimum. So this is the curve y equals to x cube. This x cube is lesser than it. Then this one. So y equals to 1. This is y equals to x cube. This is 1, this is 0. So at x equals to 1, it has surface. So not differentiable at x equals to 1. It is not differentiable at x equals to 1. Now look, what will be the possible answer? Fx is continuous for all x. This is possible answer. F dash x greater than 0 for all x greater than 1. So fx equals to look 1 for x greater than 1. So f dash x equals to 0, x greater than 1. So this one is not true. Fx is not differentiable for all x. It is not differentiable at x equals to 1. At x equals to 1. And fx is not differentiable for two values of x. For two values of x. So it is not differentiable for only one value, that is x equals to 1. So this is also not correct. This is not correct. So fx is continuous and fx is not differentiable for all x. Listen again. This is y equals to x cube, look, this curve. This is parabola, this is straight line. Up to 0, this is the minimum. 0 to 1, this and this. So x cube is minimum. And for greater than 1, this type. So this is also most interesting problem. Now you consider one more interesting problem. So a minus 1 to 1 domain to capital R. The differential function defined by a function defined by fx equals to this. K be set of points at which f is not differentiable. Then K has 3 elements, 5 elements, 2 elements, 1 elements. So draw the graph. Y equals to x square plus y square equals to 1. This is a circle but y less than 0. So this is semicircle. So center is 1, center is 0, 0, radius is 1. So this type of circle below x-axis, and y equals to minus mod x minus mod x. So this one mod x minus mod x. So this is y equals to x, this is y equals to minus x, x greater than 0. Y equals to x, x less than 0. This is y equals to minus mod x, plus mod x is this type. So this is 1, and this is minus 1, this is plus 1, and this is 0. Now see the restriction. Maximum of these two graphs. Now this part, and this part. So they intersect at. So y equals to x and y square equals to 1 minus x square. So y equals to x. So 2x square suman 1. X equals to 1 by root 2. Minus plus minus 1 by root 2. So this is minus 1 by root 2. So this is plus 1 by root 2. So domain is minus 1 to plus 1. So in minus 1 to minus 1 by root 2. So this one and this. So this is maximum. So this part is cancel out. This part is cancel out. This one. And from 1 by 2 to 0. So this card and this card. So this card is cancel out. This is maximum. And from 0 to 1 by root 2, this card and this card. So this is below. So we are getting this one. So this one is cancel out. And 1 by root 2 to 1. So this part is cancel out. So we are getting figure like this. So this is minus 1. 1 by minus 1 by root 2. 0. 1 by root 2. This is 1. So this type of arc, then this type of arc, then circle. So minus 1. So this is 1 by root 2. This is circle. This is y equals to x. So we get one surface. Different curve. Y sum x, and this is y equals to minus root over 1 minus x square. This is mod x surface. Here also surface. Surface. So how many surface within this interval? Minus 1 plus 1 is not included. So minus 1 by root 2, 0 and 1 by root 2. So 3 elements where fx is not differentiable. So draw the graph, then maximum value. So this is our final graph. So this is one point where it is not differentiable. This is circle part and this is straight line. Here it is surface, y equals to minus mod x, and here also. So we are getting 3 points. Not differentiable at 3 points. Now we consider one more problem. Same type of problem. Y equals to 1 minus x. So x plus y equals to 1. And this is y equals to 1 plus x, y minus x equals to 1. And y equals to 2. So y equals to 2. This is 0, 2. Y equals to 2. 1, 1, minus 1. So first line is x by 1, y by 1 equals to 1. So this is x plus y equals to 1. Second one is x by minus 1 or y equals to 1. So this is minus 1, 0, this is 1, 0. Actually this graph is y equals to 1 plus mod x. Now if this is y equals to 1 plus x, y equals to 1 plus x, this is 1 minus x. Now this is y equals to 2, y equals to 2, so x equals to 1, so this is x equals to 1. Y equals to 2, y equals to 2, and this is x plus y equals to 1. So what is x? X is minus 1, so this is also minus 1. Now we see the restriction, maximum. So we are getting this graph, and this graph. So what is the maximum? This one is maximum. So this part is cancelled out. This part is cancelled out. Now this is 0, 1. Then x equals to 0. This is 1, this is second, this one is third. So this is maximum. So this part is present, then maximum. This is maximum. So this part is cancelled out. This part is cancelled out. 0 to 1. This and this. So this part is cancelled out. This part is cancelled out. 0 to 1 we are getting this. And for greater than 1, this is one graph, this is this. So this part is cancelled out. This part is cancelled out. We are getting this one. So what is our final graph? You look, minus 1 to plus 1. So this is y equals to 2. Y equals to 2. And this is y equals to 1 minus x. This is y equals to 1 plus x. So finally we are getting this type of curve. So from figure it is obvious that it is not differentiable at x equals to minus 1 and at x equals to plus 1. So which is not differentiable at x equals to 2. Now we consider one more problem. So fx equals to maximum mod x square. This is mod x less than equals to 2. This implies this one. Now see the restriction, mod x less than equals to 4, minus 4 less than equals to x less than equals to 4. This is 2 less than equals to mod x. That is mod x greater than equals to 2. Mod x greater than equals to 2. Mod x greater than equals to 2. So x greater than, only greater than, x greater than 2 and x less than minus 2. So for the first one, minus 2 to plus 2. This is minus 2. This is plus 2. 0. This is 4. This one is minus 4. First restriction is minus 2 to plus 2. So mod x. So this is up to 2, this is up to minus 2. Then x square 0 at x equals to 2, y equals to 4. This is 2, this is 4. 4, this is 4. So 2, this is 4. At 2, this is minus 4. So between 0 to 1, minus 1 to plus 1, the graph of y equals to x square, we have already discussed, it is below y equals to x. So it cuts at 1, 0. Then this type, this is graph of mod x and mod of x square in minus 2 to plus 2. Then second one, minus 4 to plus 4, but x greater than 2, this is our restriction, 2 to 4. Common is x greater than 2 and minus 2 to 4 up to this one. So domain of this is 2 to 4 and minus 4 to minus 2. So y equals to 8 minus 2 into mod x. So 8 minus 2x, x greater than equals to 0. So 8 plus 2x, x less than equals to 0. So this is 2, this is 4. Now if we draw the figure, 8 will be double of it. So this is 8. This is 8. 0, 8. 0, 8. So y plus 2x equals to 8. So y by 8, x by 4 equals to 1. At x equals to 2, it is 2. So this is a straight line. So we are getting a straight line like this. But look, this part is not absent. This part is not present because 2 to 4. Now at 2 equals to 4, it is 4. That is why this and this same. This point, the curve cuts y equals to x square at 2, 4. At 2, 4. And second one, y minus 2x equals to 8. Y by 8 minus x by 4 equals to 1. 0, 8. And at it x-axis at minus 4. So at minus 2 it is 4. So we are getting a figure like this. But this part is not present. So only up to this. And this one is also not present. So figure is like this one. Then this to this and this to this for second one. And for the first one, we have to find maximum. So the curve is, this is y equals to x square, it is y equals to x. So maximum, this one is maximum. So this part is present, this part is not present. Actually figure will be like this. And this is y equals to x, this is x square, not present. So this one. So this one is not present. Again this one is present. This is cancel out. This one is present. So this is y equals to x square. This is also y equals to x square. So figure will be like this. So this part is cancel out. This part is cancel out. This part is cancel out. So at x equals to minus 2, there is a surface. At x equals to minus 1, this is parabolic arch, this is straight line. So there is one surface. Mod x, this is one surface. This one, This is 1, but this is parabolic arch. This is surface, and this one is surface. So 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. So how many points? So -2, -1, 0, 1, 2. So there are 5 points at which fx is not differentiable. So this is also most important problem. So look, if you know the concept of limit, if you have concept of limit, you can solve this problem. So this is also problem of JEE Main. From figure you can conclude. So this part is most important and most interesting also. So thank you for today.